Welcome back to Just Academy Mathematics channel, where we make you a mathematics genius. Sequel to our last class on simplification of algebraic expressions. This is a continuation. As you can see, this is example 10. I have done 1 to 9 in the last class, so make sure you see the 1 to 9 to enable you to understand what is happening here. So in this class, I'm going to continue from example 10. This is still part of our quadratic series, though we're going to be seeing some expressions that are not quadratic, but we are not done with quadratic series. After now, we are still going back to touch other methods of solving quadratic equation, but this is what we have for today. So we are asked to simplify this. If you look at the equation carefully, you will notice that except you want to do it off heart, therefore you can go and factorize this and get the two brackets that represent this, and this. But let's show it. So we're going to factorize each of them as follows. So the first one is 2s squared. 2s squared plus s minus 6. We are going to factorize that one. So let me draw here. I hope that place will be enough. We'll have to manage it. That is the up one. Then the down one, 9s squared plus 6s plus 1. If it can be factorized, we'll also factorize that one here. Then followed by 3s squared minus 2s minus 1. If that can be factorized, we will do the same thing there. And then we'll have s squared plus x minus 2. So let's go. So first, let's factorize this. Add to give you 1 times to give you minus 12. That should be 4 and 3. And that should be plus 4 minus 3. So here is 2s squared plus 4x minus 3x minus 6. What is common there? 2s is outside. If 2s come outside, what will be here? X plus 2. What is common here? Minus 3 is outside. What will remain? It will remain s, of course, plus 2. If we take the common factor out, which is s plus 2, what will remain? It will remain 2s minus 3. So this is the factorization of this. Now, the same way, let's factorize this. We'll look for two numbers to add to give us 6 times to give us 9. That should be 3 and 3. So this is 9x squared plus 3s plus 3s plus 1. Of course, what is common here? 3s will come out. What will remain? It will remain 3x plus 1. What is common here? Nothing. When nothing is common, 1 is common. Of course, plus 1. It will remain 3s plus 1. Of course, we'll take the common bracket out, which is 3s plus 1. It will remain what? 3s plus 1. The same pattern will factorize this. Add to give you 2 times to give you minus 3. That should be minus 3 plus 1. Minus 3 plus 1 will work. That is 3s squared minus 3s plus 1 x, or rather plus 1 minus 1 plus x minus 1. What is common here? 3x. What will remain? X minus 1. What is common here? Of course, plus 1. What will remain? X minus 1. Bring out the common factor, s minus 1. Remaining what here? 3s plus 1. So that is the factorization of that one. The same thing here. Add to give you 1 times to give you minus 2. That should be 2 minus 2 plus 1. Minus 2 plus 1. 2 plus 2 minus 1. Plus 2 minus 1. Plus 2 minus 1. S squared plus 2 minus 1 minus x plus 2x minus 2 plus 2 minus 1. What is common here? X. What will remain here? X minus 1. What is common here? Plus 2. What will remain here? S minus 1. So we have what? The common factor, s minus 1. What will remain here? S plus What will remain here? 2. So we have succeeded in factorizing the 4. So we'll now come here and substitute. We'll say therefore the first one, which is this, is what? Is x plus 2 times 2s minus 3 over the down one. What is there? 3s plus 1 times 3s plus 1 times, what do we have this side? Up here, which is this, is x minus 1 times 3s plus 1. Down we have x minus 1 times s plus 2. So since it's multiplication, we can just cancel out the common values. 3s plus 1 can cancel 3s plus 1. S minus 1 can cancel s minus 1. S plus 2 can cancel s plus 2. So at the end of the day, we are left with 2s minus 3 all over what? All over 3s plus 1. And this is the answer. There is nothing to do again, so we'll stop here. So as you can see, for this one, it's just all about factorizing each of them, because if you don't factorize, you won't know what to cancel out. When you factorize each of them, then you can see what is coming out. Okay, let's see more. Example 11. Look at example 11. Look at example 11. Look at example 11. So for example 11, we are given to simplify this. Now, I don't need to do it separately. We'll just go straight and do them, because they are just things we can do directly without doing them separately. For instance, this one, what will come out here is s squared, obviously. So if s squared is out here, what will remain here is x minus y. Are you there? That is for that one. Then for this one here, this is s squared plus y squared. We'll retain it here. That is not difference of 2 square. It's not minus. Then for this, we'll have divide by. Later we'll bring in the times. Let's put divide first. Here, what is common? Of course, ax is common. Ax is outside. What will remain? It will remain x minus y. Down, what is common? 2x is common. If 2s is outside, what will remain? It will remain s squared plus y squared. Okay? Times. Here, what is common? A is common. What will remain? S squared minus y squared. Down, what is common? S squared is common. What will remain? It will remain s squared minus y squared. Is that? Yes, of course. That is it. So let's swap this, then we can cancel. Obviously, we can see some of them are already canceling out safe. This, but we can't. Let's swap first. S squared bracket s minus y over s squared plus y squared times what? 2s bracket s squared plus y squared as bracket s minus y, then times a bracket s squared minus y squared s squared bracket s squared minus y squared. So we can cancel out. Of course, this can cancel this directly. And this can cancel this. And this can cancel this. And even this s squared can cancel this s squared. And a here can even cancel this a. Even this s can cancel this s. So at the end of the day, we're obviously left with 2. There is nothing remaining again apart from 2 in the numerator. So that is 2 over 1. 2 over 1 is 2. So the answer is 2. Can you see that now? That is interesting. So after cancelling, we are left with 2. Okay, let me show you maybe two more. Now that brings us to number 12. Number 12, solution. We want to factorize this example 12. So just as you can see, this difference of two square here, I don't know, 8 is common here, so we need to factorize this one up. Let's factorize that one here. That is 8s squared minus 12xy plus 4y squared. Add to give us 12 times to give us, that will be, is it 8 times 4 now? 8 times 4, yes, 8 times 4, which is 32. So we need something we'll add to give us 12 times to give us 32. Add to give us 12. You know how to do it anyway. We've passed that level, so I don't need to be showing it again. But I know that 4 and 8 should work. Minus 4 minus 8 is minus 12. Minus 4 times minus 8 should give us minus 32. So let's use 8s squared minus 8sy minus 4xy plus 4y squared. Here, for this first pair, 8s is out. What will remain? It will remain s minus y. Here, what is common? Minus 4y is out. What will remain? It will remain s minus what? Y. Take the common bracket out. S minus y times 8s minus 4y. But something is still common. I will have seen it here from beginning. That's 3. Abi? Is it 3 or 4? 4 is common before, but let's bring it out here from this second bracket. So we have s minus y times, if 4 comes out here, you have 2s minus y times what? Times 4. So the factorization of this up one, look at it. So let's do this down one here, because those two can do them direct. That is 4s squared minus 2sy minus 2y squared. We'll look for two numbers we'll add to give us minus 2 times to give us 8. 8 and minus 2. 8, 4 and 2 should work. Minus 4 plus 2. Minus 4 plus 2 will work. 4s squared minus 4sy plus 2sy minus 2y squared. What is common? 4s is out. What will remain? To remain s minus y. What is common here? Plus 2y is out. What will remain? S minus y. Take the common bracket. We'll take that s minus y is out. What will remain? It will remain 4s plus 2y. Again, something is common here. So we have s minus y times, if 2 comes out, you have 2s plus y times 2. Does that make sense now? Now let's put it there. Therefore, we are saying that this means, this up here means x minus y times 2s minus y times 4 over this one means 8 is outside, remaining x minus y, divide by up 4 is out. What will remain? It will remain 4s squared minus y squared. Then here is x minus y times 2s plus y times 2. Let's change it to times. If we are changing to times, we have that s minus y times 2s minus y times 4 over 8 times s minus y. If this one come up, you have times here. That is times what? X minus y, 2s plus y times 2. This one will come down here 4 times. Remember, this difference of 2 square of what? 2s minus y times 2s plus y by difference of 2 square. So we can cancel out. S minus y will cancel s minus y. 2s plus y will cancel 2s plus y. 2s minus y will cancel 2s minus y. 4 will cancel 4. 2 here, 1. 2 here, 4 remaining. So what do we have left? At the end of the day, we are left with s minus y over what? Over 4. That is it. So it's all about factorization. That is why I decided to treat this under quadratic. All these exam questions, you can see I'm treating them under quadratic. So because most of the things we are doing is quadratic related to quadratic. Let's close with this. Look at this question. Look at this example 13. So example 13, say we are to simplify this. The work is this first one here. Let's start by simplifying this first one here, which is a raised to the power of 6 minus 7a raised to the power of 3 minus 8. That is where the work is. Let's say break that one down, then we'll now know how to go about these ones. So for this one now, we can say that a raised to the power of what? A raised to the power of 3 square minus 7 a raised to the power of 3. Are you there now? Minus 8. So we can even say let p be something, or we can bring in another letter so that we can be able to factorize this. But this is now, see this a raised to the power of 3 as one number. In fact, to avoid confusion, let p be equals to a raised to the power of 3. So that here is p squared minus 7p minus 8. Let's factorize this. You factorize this, add to give you 7 minus 7 times to give you 8. That should be 8 minus 8 plus 1. So we have p squared minus 8p plus 1p minus 8. What is out? P is out, remaining p minus 8. What is out? Plus 1 is out, remaining p minus 8. So we are saying that p minus 8 is times in what? P plus 1. So if we record the value now, anywhere we see p, you put what? A raised to the power of what? A raised to the power of 3 minus 8 times a raised to the power of 3 plus 1. Can you see? So this is even where the work is. In fact, let me separate here first. Or let me leave it for now. Now, this one means a raised to the power of 3 minus 2 raised to the power of 3 times a raised to the power of 3 plus 1 raised to the power of 3. So these two means something very long. The identity of this means a minus 2 times a square plus 2a minus plus 2 square. That is the identity of this one. The identity of this one is a square, not a square, just a plus 1 bracket a square minus a times 1, a plus 1 square. That is the identity. So in other words, we are saying that this whole thing here means a minus 2 bracket a plus 1 bracket a square plus 2a plus 4 times a square minus a plus 1. That is the factorization of only this. And if you look at these ones here, you will notice that this one now is corresponding here, and this one is corresponding here. So we don't even need to factorize all those ones. Look at what we'll do now. So look at what we'll do. So we'll come here now in the place of this up one. In this place, we'll put a minus 2 times a plus 1 times a square plus 2a plus 4 times a square minus a plus 1, then over a square minus a minus 2 times 2 over a square plus 2a plus 4 times 3 over a square minus a plus 1. So what this means, obviously, is that we can cancel out from here first and know what is remaining. This one can cancel this one with 4. A square plus the same thing. Even this one can cancel this one. They are the same. So we're left with this and this. And obviously, even this, if you factorize this, because if you open this bracket now, you have a square 2s, a square plus a minus. So the opening of this bracket will even give you this one. Yes, because this one you are seeing, if you factorize this one, this is what you will get. So this will say cancel this. The answer is 6. But let me just write it out. What I'm saying is that if you open this bracket, you get this. Or if you factorize this, this is a minus 2 bracket a plus 1 over. If you factorize this one, you still get a minus 2 bracket a plus 1. Then times what? We have cancelled out this one now. Times 2 times 3. So this will cancel this to give you 1. That is 1 times 2 times 3. So the answer is still 6. So you can see, no matter how complex it is, if you factorize it, you will get to somewhere. So that is it for this class. In our next class, I'm going to be showing you how to evaluate